Today, block 18 for those of you in the cybersecurity boot camp. For the rest of you, it looks like we're working on Python modules, importing different tools to your program, manipulating the file system through the module OS, exploring the file system, checking for files. We got some exercises to knock out, so let's get started. So modules. Modules are external tools outside of your Python script. Basically, somebody else wrote a program in Python, a useful tool, and now you can import it into your script or program to be used. So for example, OS stands for operating system. That's an operating system module. And at the very top of your Python script, you are going to perform your imports. OS is probably a class. What is a class, you ask? Well, I'll give you a simple example. Imagine you have a class named car. Within that class, you would have functions for different functions of the car. Inside of classes, functions are commonly known as methods. So you might have a method in your car class called honk, and that would maybe print an output that says honk with an exclamation mark, or maybe it would grab an audio file that does that. You would have another method in your class for drive or turn on. You might have variables built into that class. I think they're called attributes in classes for things like your tires, your windows, parts of your car that aren't activities or active functions, but are parts of the car, attributes of the car. So that being said, when you see something like we're importing OS here, and then we are using OS, as indicated here, this get CWD is likely a method that lives inside the OS class, inside of the OS script file. It is being called as indicated by these two parentheses at the end of it, and this dot is the main indicator that it is something that lives within OS. You could have something like os.getCWD and then even another dot. Let's see if there's an example of that somewhere. Yeah, right here. So os, dot path dot get size. That means path lives inside OS, and get size, this method, lives inside of the path, which might be could be a function inside or another. I don't know if it's another class inside of it. I'd have to check. Feel free to leave an answer in the comments for clarity on that one. But not only can you import just OS, you can import certain tools from within OS like this. And when you set it up like this with from OS import get CWD, you no longer have to prepend OS dot in front of the function get CWD. And CWD is current working directory, so that would basically print out the current directory that your script is reading from or inside of. Username for uname, and some of them are pretty self-explanatory. This is going to be a function that makes a directory, it looks like. We're going to receive the name of the directory as an input to our function. We are then going to create a p variable which probably stands for path. I prefer using full words just for readability purposes rather than letters. You start seeing too many letters, it becomes a jumble. Now we are having the OS import perform the list directory function and feeding in this path as its parameter, as its argument. as its input, and it is then performing an if conditional saying if directory 1, which was fed in here, and then initially came in through here, which came in through a user input, so here to here to here to here, we're going to check to see if directory 1 exists in this path. And if it does, if the if conditional resolves as true, we're going to return the string directory already exists. If it resolves as false and the directory is not in the path, we're going to set up a make directory method that has the path here. Interestingly, they could have listed P here instead of rewriting it. However, we'll just ignore that. They are concatenating the directory to the end of this to create a new directory. And then it will return directory successfully created. Let me know if you have any questions on that, and I'm just going to keep moving through and reading through this code. This one is going to check to see if a file exists. This one will take two arguments, the file name and a path. The first thing that happens is we are going to change directory in our system so that when we perform these other ones, we are already in the proper directory. So if you're used to using terminal in Linux, imagine that you've just done a cd or change directory to a particular path. And in this case, we're feeding this argument in for the path. So imagine you did cd home labs user logs. If this path exists, os.path.exists, we're checking this file name, feeding it into this function. That's a built-in function of path, which is built into OS. If it exists, go ahead and return the file name. If it doesn't, actually not just the file name, we're returning the size of the file name. And I do believe you'll just see a pure integer, which is returned in bits. Bits or bytes? Bits, I think. I have to check on that, it's important. On to the next one. Just to mention real quick, you can throw functions into a print built-in method, and that should generally work to output the return of the function into your console or terminal. Write a function called delete file, receives the file name as an input, as an argument. Hopefully you're starting to get the kind of the structure of this. It wants us to make a function, add a parameter or two, check to see if something exists first generally before we make any changes. If it does exist, we'll go ahead and perform a method built into OS called remove, and then feeding that parameter in, it will return the file was deleted if successful. The else statement here, if the file does not exist within the path, the file is returning a string, or rather it's returning a string saying the file wasn't found, which is pretty much a good goal anyway since we're trying to delete a file, or a good result. Alright, let's start on some problems, and I'm going to go ahead and delete all my work without looking at it, and we'll just start as fresh as possible. I'm going to, I don't know if we need to with built-in Jupyter Labs workspace here, but I'm going to go ahead and import OS as I would in a normal script. We are going to, number one, write a function called checkFile. So define check file and finish the function line with a colon, giving ourselves parentheses to feed in our two parameters, file name and dir name. You don't necessarily need a space here, but I like it for readability. If your function is correctly syntactic, when you press enter, it should automatically indent for you so you can start writing the line of code. So let's see, check if the file exists in that path. So if file name let's see, we need to check if a file name exists in a path. And I know it's os.path.exists. Do we need to feed in the directory here is my question. So let's see. The file exists, that's old output. It doesn't give us a path up here. Receives a file name, checks if the file, I probably just pulled this from above to test out the code. Checks if the file exists in the path. So we probably want to change directory first. So let's scroll up and pull this sucker, os.change directory. That way we're setting ourselves up for success. Here, os.change directory is file name os.path.exists. If, whoops, let's see, if, and we need to just feed this in as an argument. And there's a reason I didn't really practice this too much before presenting the lesson. I want you to kind of watch someone troubleshoot and figure out how to solve a problem when they don't know exactly the answer right away, or they don't have it to paste off of another text editor. So I found it helpful when I was first learning. If os.path.exists file name, print this file exists. Else print, we probably just want to return it, don't we? The stuff up here doesn't contain parentheses. I like to maintain the same standard as I would with using a print method. You can use parentheses and quotes like this, as I recall. We'll find out soon enough if I'm wrong. Okay. This file does not exist. Check file. We've got the function made. We've got the two arguments fed in. We are changing to a directory based on the directory name parameter. We are then checking, once we're there, if the os.path.exists file name, so if the path exists, if the file rather exists, within the path that we changed to, and it should return. So now we need to call the function and print it out. This is where I'll go ahead and I got lucky and have some old output here. Copy, and we will do a print to print out the return of the function that we're calling, and log. Let's do something wrong first. Let's see if we can do, no, it's not smart enough to highlight it and do quotes in between, or quotes on the outside. That's something you can do in VS Code likely, is highlight a variable and then press the quotes and it'll surround it rather than deleting it. And, oh, rip. See if I can copy it. Control C, Control V. Yep, all right. We need to delete this file because we're only trying to specify a directory for the directory name. So I'm feeding in the directory name here, the file name here. It gets fed into this, down to this for the directory name, down to this for the file name. Let's check. This file does not exist. So I did Shift Enter to run the code without pressing the play button at the top of the menu there. And log.txt does in fact exist. I'm curious to see if I can break it by just running it like this. File name, log.txt. Let's try and break it even further by changing to root and then checking. File does not exist. And let's print list_dir. Print ls.list_dir. Dir list? No, CWD boys and gals. Current working directory. OS has no at get CWD fam. Get CWD. Okay, cool. So it looks like if we're in the wrong directory, it is functioning. So it's a good way to test something by trying to break it. All right, that should cover it for problem 1. Let's delete this without looking at it and try out problem 2. Write a function called list file. Let's import OS as we would do normally in a new script, a new .py file, .py. Receives a directory name as an input. We've got def list file. Receives directory name as an input. We'll call it the same thing, dir name, and then lists all the files and directories and puts it in a list. Okay. So list dir equals, so we need to list all files and directories inside of the dir name. So I'm guessing that list dir, can't remember exactly, but I think that's the method based on the naming conventions of the other stuff. And I did it earlier, so I kind of remember. List dir name. Let's just print this out to see what it looks like, see if it throws an error. Return print. Since we're living in a function, we need to. No, it's not going to work, fam. Return list dir, and then we will print the function call. List file. We're going to pull the same file from before, since we know this one exists. List file, dir name, logs. We need quotation marks. Alright, so we have a function made with directory name to be fed in as a parameter, as an argument, creating a variable, assigning the output of a list dir OS method, returning list dir. Let's run the sucker. Alright, so that's working. Pat on the back for guessing the right method name there. And we need to now, oh, it's already in a list. How nice is that? List all the files and directory and puts it in a list. We can double check the list that it's, I mean, it looks like a list just based on the output. You've got your brackets on either side and items separated by commas. It's not technically one line because it's, you know, breaking into a second line, but that is, you know, it's a line. Let's do print type list dir and try that out. Class list, we are done. So we've created a list. It actually does the creation of a list on its own with this method, it seems like. We've called the function, we've printed the list. So problem 3, delete before we see any of it. All right, I was doing some very professional work previously. Problem 3, write a function, import OS, seems like we're using that today. Def check dir, colon to finish the function, receives a directory as an input. Stick with input dir. Check if the directory exists. We did path, we did file exists previously. Okay. Is it going to be the same as this, but with dir name? Is that what's happening right now? We just need to check the directory. We don't need a file parameter fed in. We don't need to change directory to check if a directory exists. We need to feed directory name into here. We need to only have the directory argument. We've got 1 parenthesis 1 parenthesis 1 and 1, so we've got the right amount of parentheses. Change this to check dir for accuracy. Check dir. Check dir. It's not lost to me that saying dir over and over is funny sounding. The file exists. Let's try something that wouldn't exist. That's what we did. Oh, does not exist. Alright. Let's try root. Yeah, that exists. Let's try home. Let's try outman. Alright, looks like we got this too. It's a copy and paste and replace some stuff on the file exists method. Installing custom modules. Okay. So this took me a while to figure out. I don't know why when I was learning Python, but between like apt and pip and so many other different package management softwares, they're all similar. They're just living within different languages, platforms, operating systems. apt is Linux, pip is Python. You might have heard of like Homebrew, Chocolatey. There's like third-party ones that accomplish similar ones that people prefer. I feel like Homebrew's on Mac and Chocolaty's on Windows, but I could be wrong. Feel free to correct me in the comments. But ultimately, some modules like OS live inside the Python package when you install it. There are a ton of other modules that people have created that live elsewhere. Pip seems to be package management that contains most of what you need. Don't ask me what pip means right now. I haven't looked it up. This is the standard syntax on your console or command line for installing pip. When you install it, it doesn't install to the directory that your script is in. I believe it installs to a pre-made directory specifically for packages. I'm not sure if that's added at this point via Python installation or your maybe VS Code's installation or pip's installation itself, but it all goes to a particular directory set aside specifically for packages. Correct me if I'm wrong. But once you do this, you're able to import the module much like we did with OS previously. Let's see here. Write an import statement, write all the other functions, except the main function, main being main and then the parentheses at the bottom of the script to try and organize things. Auxiliary functions are everything else technically. I don't call them auxiliary, I just call everything functions or methods if they're inside a class. Good go. Actually, this is demonstration. Let's keep it. Let's move on to see demo. Okay. So we're making a directory. This is literally just taking everything we did in the last 3 problems, pasting it right here, the auxiliary function, and then creating a main function for the main execution of the code. So in this, let's fix this a little bit to make it prettier. But in the main function here, we are taking the user input and then we are calling the main function, the main workhorse of the script here. So input created there. I could call this user dir and user dir. And then it's smart enough to know that this parameter goes here when the function gets called, and then it starts its whole work and checks for directory existence and creates it. It just calls main down at the bottom. So you write a script and then it's a quick copy paste job, writing an extra function at the bottom to be your main function. You'll learn something called dunder main, which I think is more actually common in professional use at the bottom of scripts. It helps with modularity. That's all I'm going to say now because I know I'll say something wrong beyond that. But feel free to look up dunder main and dunder name and what they mean for Python modules and why they're important. Feel free to leave that information in the comments as well to help your fellow students. Yeah, as you can see, the only addition is main, and then we're doing the same darn thing again. We're just printing out the return of the function that we're calling with our 2 arguments fed in. Rinse and repeat, fam. Rinse and repeat. Exercise. Get going. Let's start fresh. All right. Rewrite. Oh no, it's the same thing over. Come on now. We already done did it. It's the same junk again, guys. Check file. Here's our function that we already wrote. All we're doing is taking the function call that's printed out on a single line, throwing it into the main function. Main function is an empty function, and then we're just calling the dang thing down here. That's it. Same dang thing again. Same dang thing again. Trying to look for something different to show you, but there's nothing. Opening and reading files. Here we go. This is some real stuff. Let's go. Let's just leave that for now. That's the demonstration. All right. Opening and reading files in Python. Open a file. This method is not something you need to import. It is for sure built in. You don't even need to do import open like you do import OS. You just use it. It's there like a print or input methods. So we can perform a couple different things with the file once we have performed this initial one. And so just some clarity here, when you perform this function on a file that lives in your system, you're not actually going to see a window open up with the file. The program is opening it up so that it can see what's in it, your Python program specifically. But you're not going to see a file open up that has, opened your Explorer or your directories and is showing you a visual of it. Look at these typos. Get good. Once you have opened the file, object has a few methods available. Closes the file. That's probably something you want to have at the end of your script when you're using this. This is going to return the file content to be read, excluding writing and executing in that situation. Read line is going to return a single line from a file, and each time that you execute this or call this function, it's going to drop to the next line and read that for you. This returns a literal data type list of the file's lines in a list format that you can then use a for loop on. Seek, pretend you're in Notepad and you are, here. Oh goodness, this actually worked for us. What a coincidence. If you're all the way up at here, you're at seek position 0. And for each cursor movement, add 1 to your cursor position. And that's what seek is. But you're not seeing it, it's happening in the back end. Goodness, that threw me off. All right. Will tell you what cursor position you're currently in. I haven't used these two in a project or at work, so I can't think of a use case for them. So let's start with the open method. File name is the variable established. Let's create some better readability here for the poor coder that has to read this stuff. File name, creating a variable called file name, and opening the file name here, which if it were being fed in as an argument wouldn't have quotes around it. It would be a variable. Mode is going to be what type of mode open is it in. So read the file once you open it. Be prepared to write in the file or update the file. Exclusive creation. I don't understand what they're saying there. This means executable in my knowledge, my very small amount of knowledge. A opens a file and appends. So in Linux, if you've ever used this in the command line to take an output and append it to the back of a file, and if the file doesn't exist, it creates it. Same dang thing. Opens in text mode. Opens in binary mode. This doesn't literally open a text editor, it just basically tells the system that it can expect some sort of .txt, and this, it can expect some other file that's in binary. That's all I can give you on that. I'm not sure exactly what this does yet, but if we have to use it, we'll find out. Now, we are creating our file name here, assigning it the string. This is probably an existing file. It looks like a pretty common one in a Linux system. Open file, open method built into Python. Proper formatting. We've got a space here, and we are just reading the file. So if I press run, nothing happens because there's nothing happening that's being outputted. Let's try print open file and see what that tells us. It's giving us some weird details that are basically used on the back end of the program. But you can see that mode R is here. I bet if we switch this to W and run it, yeah, mode W now. So that's it. That's opening a file for now. Let's go to the next spot. File name, open file, get ready to read, and then we are adding the method .read to our file that we opened. And we'll run it, and you'll see, jack squat. Let's see. To see the content of a file, use the method called read. And we should see stuff. So let's double check a couple things since I'm not seeing an output. I've got a path that looks correct according to the notes. I've got open, is this it right here? Open file. Nope. We are opening the file name, we're preparing to read it, and we are saying read. And read returns the file content. Let's try printing this and see what we see. Nothing. I wonder if it's the code editor. Let's check some things. Let's use OS and troubleshoot. Import OS. Print os.getCwd. We're in logs. So we could technically, maybe that's the issue. We're in the place we're trying to find out. File name, password. Let's try it now. Oh, no such directory. So we don't need to have that. That's telling us the directory. So it's printing out get working directory here. Let's try listdir. We've got password right here. To see the content of a file, use a method called read. We have, let's try a different one. Let's try a different file. File name, Let's try auth.log. That's working just fine. I am wondering if I accidentally overwrote what was in password and it's now blank. So we've effectively read something. We've troubleshot it. And that's that. So let's just run it again. See, we're going. It's working. Not user error for the first time in my life. And it's huge. Not something I hear often. Good golly. Goodness gracious. Alright, let's get rid of it. Clearly we've erred. Let's do what we know is blank. Alright, on to the next one. This tells you the cursor position. It's 0, which means at the very top left. If we set up a seek command before that, it's effectively like moving your cursor and clicking into a new spot. So 5 spots up, seek. Ooh, look at that, doesn't care about white space. So that's like effectively if we go 0, 1, 2, 3, 4, 5. That's where the cursor is when we tell it to go to 5. I believe. Correct me if I'm wrong. Here's some further testing of that. Something that I thought was interesting was that when I did this, it only shows the last one. I had to print out these two for it to show the 5 after it tells and then move again to 0 and tell again. No idea why, I just thought it was interesting. If you want to read line by line, you're going to use the read line method. This, the reason I had it pasted twice was because each time you call the function, it jumps to the next line. So let's just call it once. Oh, you know, I erased the gosh darn thing, so it's not there. Auth.log. This is where we want to use this. Next, 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 next. Oh, it's not doing it. Play. 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 I swear it's switching lines. Let's do it a bunch of times in a row to see if all the lines are just exactly the same. They're close. We got some different times though, but a couple of them are exactly the same. No, they're all different. You can see what it does. Alright, open file.readLine. Reads the line, call it again, jumps to the next line, reads that one. This is more useful. We are reading all of the lines. When you perform this method, it creates a list of all the lines. And then once we have a list of all the lines, we can create a for loop, creating an iterable or a variable in place called line. It's going to iterate through each line, and each time it iterates through a line, it prints it and then restarts the loop. Oh man, we're killing ourselves with this. Let's see what else there is. What else we got? Where's that list? Let's go with this one. IP tables. Where even the heck are we? All right. Heck. IP tables log.txt. Is that what it was? Invisible audience. IP tables. IP table sys log.txt. IP tables sys log.txt. Send it. All right. Let's do print lines, print read lines, so you can see what that looks like. Open file, read lines, send it. Boom, list. See it right there. You can see right away it's a list. Don't tell me I never taught you nothing. List. I've covered for loops in a previous video. Feel free to check it out. Feel free to comment if I said wrong stuff. I don't care if you comment or like otherwise. I don't care if you ding that bell. Just learn. All right. Let's get rid of this. Go to the next one. Close a file when you're done reading a file. You want to close it to vacate the space in memory. So when you're done, just close the dang thing. After we read everything, see what happens. Oh man, got us again. Not this time. Not this time. Alright, let's try it out. It does it and then it closes it. It doesn't show any visual, I don't think. I'm curious though. Something that we do have here that's new is instead of creating a variable and saying open file and then using this here, we are trying a new standard, a new approach called with, and then it lists the function that's built in to call, and then it assigns the variable name here with the keyword as. So now it's just the letter F for our file name. This is effectively the same thing as, I'm not going to delete all that, that'd be silly. F equals, same thing. This seems more verbose and wordy to me. I'm not sure why it's more optimal. I prefer using full words for clarity. We are opening a file, we are reading it, we are going through a line in the file. For line in file, print line. Is that going to even work? Yeah, all right. To prevent you, there's no need to close the file here, okay. To prevent you from oh, here we go, I can read. To prevent you from forgetting to close a file, use a method that opens and closes the file automatically. That's the advantage of it, rather than assigning a variable with this. So this opens and closes the file and you don't have to remember it. Just learn something new. All right, cool. Yeah. Demonstration. What else we got here? Not gonna get us this time. No, that jump. Got us with that though. All right, reads the entire file. Goes back to the beginning of the file. That's gonna be seek most likely. Iterates over the file. Prints each line. Closes the file. Reads the file. Puts the cursor at the front of the file. Loops through a list that's created here. Prints out each one, closes. We just learned that we could use with. So I'm surprised they're not using it. And then here, we're feeding in as an argument the file. Put in some spaces. Give us some breathing room. Gosh. That's better. F for file, assigned to opening the file, calling the function, lives within main. I guess it's cleaner or more usable for modularity purposes. A reminder to look up dunder main, dunder name. Exercises, we did it, we're here. Look at how not far down we are. We're gonna make this a two-parter. Exercise problem 1, write a script that opens log.txt, prints the entire file. All right. Prints the entire file, goes back to the beginning of the file, Prints only the first line, so that's the read lines, not read lines method, but read line, not plural. Then prints each line, then closes the file. All right, well, let's do top and bottom one first with open file name. We want to read as F, I think that's correct. Prints the entire file. Print F, prints the entire file. What am I doing? I'm just learning bad habits. Prints the entire file. Goes back to the beginning of the file. I guess printing it, does that make it go elsewhere for the cursor? File.seek. Yeah. File.seek, back to the beginning. File.read line for line in read lines. File name. Yeah, file dot. I wasn't sure if I had to feed it into this or put it at the front. I have to, and I hardly remember when which is which, unless I've used it a bunch. I kind of just trial and error it or reference something else usually. For line in file.read lines, print good old-fashioned line. And the beautiful thing is, our new knowledge has revealed to us that this both opens and closes the gosh dang file. So that's fantastic. And it looks like we are writing it correctly. Let's run the code. Okay. Print file. This is maybe not printing the correct thing. Prints the entire file. What does it want us to do? Read? Yeah, probably that. So print file, read, seek. I'm going to add a note that says it has been sought. What does reading do? Does it move the cursor to the end? Returns the file content. Returns one line. Returns a list. ChatGPT, help me out, buddy. Reads the entire file content as a single large string. Typically you use a loop. Okay, so read outputs a string. Read lines outputs a list of each line. Okay. So they do close to the same thing, but you have to manipulate this now with a string manipulation like indexing, slicing in particular, which you can do with lists, but it's a string here on the output, it's a list here on the output. Standard convention seems to be to perform this route. I don't know what the use case is for read. Are we even in the right spot? Somebody's got to tell me these things. It has been sought. Well, let's do a tell. File.tell. Oops. Heck. Print. Should see it right after the it has been sought. There it is, 0. So it's seeking the right spot. This is outputting a string, but I'm not going to read the string when I'm already, it's redundant to read both. And read line should be reading the same thing as what's appearing in the first line of the list. No, it's not. But these are correct. It's not throwing an error. I could do prints of each one of these to exactly figure out what it is and where, but it looks like we're performing it fairly correctly. Let's kill this giant block of text. Let's write a script that opens log1.txt. Let's make this the last one. Not gonna get me. You're not gonna get me. Blank password file with open file name read as file. We need to establish a file name, don't we? Otherwise the computer's not going to know what we're talking about. File name equals, surround this sucker, change it to log1.txt. Print every line in the file without the new line character. The new line character is this guy, and it exists here, for instance, but you can't see it. But it tells the text editor to then form a new line with the next set of text. So this is a strip command, I believe, alright, so we're feeding in file name here, we're reading it for line and file, line.strip. I'm assuming now it's going to be a giant jumble. Oh, let's see. Let's do it without it and see what it looks like first. How do we strip? How do we strip a new line? That's how you strip a bracket. Looks like it, right? Text.strip. Print clean text. I didn't want to use Gemini every time, but I'm pretty sure that just produced an AI. It's just AI anyway. It's all AI. AI. Alright. Line.strip. Doesn't look different. What the heck is happening here? Oh, you know what I did? Talk to yourself. That's what you did. This did it here, but it didn't permanently change the variable here. It just did it in place here, so we would have never known. I bet you if we do, I know it, if we do strip right here, we're gonna have some goofy looking stuff. We'll see one has new lines, one doesn't. Chapow. Learn something new every day. Every day. New line's gone. Alright. We're gonna stop there because I am tired of hearing myself talk. If I said something wrong, as I inevitably have, please correct me in the comments. Other than that, I hope you learned something. Good day.